Okay, it's time to get started. Thank you everyone for joining our live lecture today. My name is Isaac and I'll be the lead instructor for the lecture. And today's topic is going to be web security. So we're going to be talking about how you can best secure your application from the various threats that are out there today. Okay, so let's go ahead and start off by talking about the kind of mindset you should have when you're building your software. Okay, and that is prepare for the worst and hope for the best. Okay, so before you start building a software project, you first need to see the scope of security needed. So, for instance, if we had a restaurant who said, "I just need a menu," which is put at a live web address. Okay, because there's not going to be any credit card transactions, no passwords, user accounts, nothing like that, we probably don't need a high level of security for something like this. However, if the same restaurant came to us and said, hey, we want you to build a website that has not only our menu, but also people can order from the menu, right? It'll process credit cards, they can sign up for deals, all that kind of stuff. So that kind of scenario, we want a higher level of security. So just go to say, don't treat every project the same as far as your security goes. It's on an as needed basis. Okay, so now let's talk about your account or your accountability as a developer. Okay, so there are certain laws that developers have to follow when building software. Okay, and the two biggest ones are PCI compliance and HIPAA. Okay, so PCI compliance is things like you can't store things like credit card information in your database just like raw format, right? It has to be encrypted, right? There's certain compliance standards you have to follow when it comes to credit card data. And then HIPAA is the same way for health data. Okay, so if you are building software in regards to that, more than likely you have a project manager that has scoped out all of those specifications, and you'll be taken care of in that regard. But maybe if you're handling a project by yourself and it has to do with one of these two fields, make sure that you read up and make sure you're following compliance. That being said, there's a lot of third-party services that handle credit card information and health information for you. So that way it never has to hit your servers and it keeps you from being liable. Okay. So next, let's talk about actors. Okay, so when you're building your software, it's hard just to think, okay, I'm going to build it in such a way it'll just, prevent everything. Okay, so you got to think of it more so in terms of actors, like who's using my software, and are they a good actor or a bad actor? Okay, so for example, a good actor is someone who goes to your website and uses it for what you built it for. Okay, so those are just regular customers and such. And the bad actor would be maybe an employee using the admin panel of your site to steal some customer information, right? So that'd be bad actors. So when you're building your software, just think in terms of good and bad actors in regards to your users, and this will help you know what standards you should implement where. Okay, so next let's talk about trust boundaries. So trust boundaries are divisions between areas of software that have different privileges. Okay, so these vary project to project, but you may have trust boundaries in regards to client server roles, network machine boundaries, encrypted channels, authentication. The list really goes on. So let's go ahead and talk about some of the more common ones and how they play a role in our security. Okay, so in regards to understanding security, you need to understand what a computer network is. Okay, and maybe you do, maybe you don't at this point, but let's go ahead and confirm that you know exactly how it works. Okay, so a network is simply a collection of computers connected by transmission medium. So when you write software to the web, it will end up being hosted on a web server. And then clients can access it using any device capable of sending a network request. Okay, so this has to do with security because when things are connected like this, it opens doors, okay, to your server, and those doors can be abused. Okay, so let's go ahead and talk about channel encryption first. So anyone on the same network as us, okay, this goes back to the previous slide. Everyone's on this network here, okay? They all can use certain tools to view your traffic, okay? So in order to have a private conversation between the client and servers, what you need to do is you need to encrypt your channel, okay? And you can do this by setting up a TLS certificate and redirecting your web traffic from HTTP to HTTPS, okay? And the S stands for secure. So you'll notice most banking websites, government websites, right? Things that have databases with sensitive information normally always are HTTPS, okay? And it's just becoming more and more the standard these days to make sure that you don't have your messages intercepted. Okay, so now let's talk about how we can enforce security for our API endpoints. Okay, so because endpoints are generally exposed, it's a good idea to set up some additional logic to verify the incoming requests. Okay, so for example, GitHub, whenever we first access GitHub, we are a guest, right? And we don't have an account. So what GitHub allows us to do is we can access public resources, but that's it, okay? And so they've set up security to where this role only allows me to view these resources. And then the same, once I sign up for an account, I'll become an authenticated user, and I can view my own resources and the public resources. But maybe if I went one step further and I was a member of an organization with an admin role, maybe I would have access to even more privy information, okay? So it's good to set up different boundaries in this regard for different user roles in regards to your endpoints, so you don't have just guests able to, access all your resources. Okay. Next, it's also good to enforce rate limits in regards to your APIs. Okay, so the reason this is important is because if an API is if an API is publicly exposed and we don't have a rate limit, that means it can be overwhelmed with requests, and that can crash our server. Okay, so let's take a good look at GitHub and how GitHub's added a rate limit security to their own API. Okay. So I'm just going to copy this request and let's paste this right in here. Okay. So let's go ahead, and as we notice, we can see that the rate limit started at 60, and then after we hit it with a request, it then went down to 59. Okay. And that way, once per hour, I only get 60 requests. So it's going to be really hard for me to overwhelm their server with requests because I only get 60 an hour. Okay, so this is an example of what, how you would set that up. Okay, so moving forward, let's go ahead and talk about the DOS attack, which is the denial of service. And this is in reference to what we were talking about, is flooding a specific machine or resource with just a ton of requests in an attempt to overload a system or prevent it from running altogether. Okay, so denial of services, right? These are one of the easiest things to prevent against. Okay, but if you're lazy, and it's actually one of the easiest things to fall prey to. So the prevention methods are this. Okay, throttling's one. Okay, and that's controlling the bandwidth. Okay, rate limiting is 2, and that is just what we saw with GitHub, right? Limiting the number of requests that can be made to specific endpoints. And then web traffic monitoring. Okay, so there's several tools for this, normally, linked to your database. And, this is a good way to keep, a real-time idea of what your server activity is like. Okay, because obviously if it's off the wall, we know that we're probably experiencing a DOS attack and we need to take countermeasures. Okay, so make sure you implement those to have best result. Okay, another kind of attack let's talk about is cross-site scripting. Okay, and it's a type of vulnerability where a user uses some script and they put that inside of an input, and then that input is submitted and it runs. Okay, so we never want them to be able to run code in our program. So to get around this or to avoid it, I should say, we're going to use a method called sanitization. Okay, and sanitization is simply the method of adding some sort of library to our program, which scrubs the inputs for data types and make sure that they are the correct format before processing them further. Okay. So let's talk about another kind of vulnerability called SQL injection. Okay, so SQL injection is pretty unique to SQL. Okay, and it's simply where the user inputs like a SQL statement in some sort of input field, and that gets executed. Okay, and when that does, they can do a lot of things with our data. Okay, so to avoid SQL injection, you use sanitization. Okay, so we just went over that, scrubbing our inputs. And also we can use object relational mapping tools. Okay, so they're also known as ORMs. Okay, so again, if you have a SQL application, make sure that you are wary of this, because SQL statements are so plain English, they're very easy to enter into text fields and be submitted. Okay, so now let's talk about another kind of vulnerability called file uploads. And this one is actually, a surprise to a lot of people, because a lot of us upload files all day long, right? So you wouldn't think that would be a vulnerability, but it actually is. And the reason is because some files are executable, like a PHP file, and what they can do is they can upload it, and then they can call the corresponding URL from their web browser. Okay, so now they're running code on your server, and they can do what they want. So to avoid against this, we use a similar tool to sanitizing. It's called a file type detector. And we just will filter out files that don't have like a .jpeg or .png, right? It'll check formats before processing them further. Okay, so beware of file uploads. Okay, so next, let's talk about another kind of vulnerability called ARP spoofing. Okay, and this is what we were talking about earlier, where you can get an interception, right, when you're sending a request in a specific network, and someone else in that same network can spoof your address resolution protocol, and then it will take your IP address, okay, and it will mix it up with the attacker's. So therefore, the traffic meant for your IP address is then sent to the attacker instead. Okay, so again, this is very commonly referred to as intercepting, okay, or ARP spoofing. So to prevent against this, it's really easy. Just implement your TLS certificate, okay, and redirect your user traffic from HTTP to HTTPS. Okay, and I can't emphasize that enough, because it's something that a lot of developers neglect to do, because it does cost a little bit of money for certification, and then it's kind of a headache on top of it. So don't be that developer that skips it just because you're lazy. Make sure that you prevent against these kind of things by getting that TLS certificate and redirecting. Okay, let's talk about another kind of spoofing called DNS spoofing. And this is less to do, with, your network, and more so to do with your DNS provider and their data resolver cache and the cache, sorry. And what it does is, it's similar to ARP spoofing, and it sends it to an incorrect IP address, except this is a lot harder to accomplish for them, because they actually have to get past the DNS provider's security, which these days is pretty tough. Okay, but again, safety is best practice. So prevention method for DNS spoofing, just like ARP, is that TLS certificate. Okay, so now let's talk about the oh so famous firewall, right? Everyone hears about firewalls, right? All growing up, every time you see a movie about the FBI or someone hacking the FBI, it's always, oh, I have to get past this firewall. And, it's a fancy word that basically just means filter, okay? So firewall is a filter that basically allows certain traffic in and other traffic not. Okay, so anytime that you have a program running sensitive information, things like that, you want to incorporate a firewall so not any traffic can come in and out of your specific network. Okay, so next, let's talk about having a plan B. Okay, so here's the thing about software is it's always evolving and there's always new ways for hackers to get around your security. Okay, so it's good to assume the worst and kind of go off the idea that one day you will get breached. So that way you can have a backup plan in place already, and you're not just up the river without a paddle. Okay, so let's go ahead and let's talk about the emergency checklist. So emergency checklist, just a series of steps to take in the event that the service goes down and maybe you're not around. Okay, so it's nice for teams of developers to have where maybe the project manager's on vacation, but that's okay because they have emergency checklists to take care of whatever they can take care of at that time, and not wait for the project manager to get back, where by then it could be very, very bad. Okay, so make sure you have one of those in place before you start building. Next, organizational privileges. So this one's pretty important because most of the time when software projects are built, they're built by more than one person, okay? And so because there's lots of hands in the cookie jar, what you want to do is you want to restrict things to an as-needed basis as far as permissions go, okay? Because people are human, and at the end of the day, you might have a software team where a developer, is responsible for building out, the database logic, right? And then that developer, has a argument with the boss and he quits. And he's so mad that he goes in and he deletes everything from the database. Okay, so now the company is in big trouble because all their data is gone. So to avoid those kind of situations, again, you only give people with the higher authority permissions to update the database, delete it, things like that. You don't just hand that privilege out to all your developers ever who were working on the project. Okay, so you can think of software like Facebook, right, where not every developer that works at Facebook has access to Facebook's database, right? Maybe they only have access to the front end code because they're a designer or something. So that being said, assign privileges accordingly. All right, now let's move on to the fun subject of protecting passwords, okay? So when encrypting passwords, first thing to know is there's a lot of different ways to encrypt a password, okay? So the way we are gonna show you here at Coder Camps is called hashing, okay? So how we're gonna do this is first we're gonna add a salt to our original password, okay? And what the salt is just a long random sequence, okay? And then we add our real password to that, okay? And then we hash it. And what the hash algorithm does is it checks that it makes sure a block of content hasn't changed, okay? So later, to have that same outcome, the user is going to have to, know the real password, okay? And it's really pretty impossible to guess that even if they gain access to salt, because they'll have to compute the entire space from scratch. So that being said, as well as encrypting our passwords, it's also a good idea to enforce a password strength rule. Okay, so we've all seen these. That's goes along the line of hey, it must have 6 characters, or it must have a special character and a number and a letter, right? It doesn't matter 100% how you do it. It's just good to force some sort of strength rule or something to that regard, so you don't have easy guessing. Okay, again, let's look at a program like Facebook. Probably one person in the world on Facebook has the password, right? So me as a hacker, I'm probably going to be able to access just at least one account if I need to on software that's big enough, okay? So to avoid this, again, you don't let your users create passwords like 123, right? That you help them help themselves in this way. All right. So now let's talk about two-factor authentication. So the simple password, right? That's one-factor authentication. But if maybe it asks for a password and then sends a text to our phone with another code, right? That's two-factor authentication. And this is very commonly used for financial institutions like banks and stuff, because they need to make sure that you are indeed the person you say you are before you access that account, because once you do, you can really make the customer's life, really hard, and as well the banks. Okay, so they want to just double check, and this double checking is through this two-factor auth. So really the great part about this is if maybe I lose my laptop, okay, or someone steals it, and maybe I have all my passwords saved into the browser, okay? So what's great is maybe they can log into my laptop and they can even try to log into my bank account. But what happens is they also have to have my mobile phone too. So unless they stole both of my devices, the chances are they're probably never going to be able to get into my account because of this two-factor auth. Okay, so depending on the software you're building, you might want to implement it, you might not want to. It just kind of depends on what your stakeholder wants. So now let's talk about security resources. Where can I go to learn about security and keep up to date with the latest incidences? So here is the top 3 resources we recommend for you to do that. Okay, so the first one is CVE, and this is just a database full of incident reports, and that way you can come here and keep it up to date on the latest, greatest prevention techniques. Okay, another one is OWASP. This is one of my favorites because it's like a Wikipedia for security, so it's fairly easy to navigate and informative. So it's another one. And finally, there is Verus. Verus is very similar to NVD. It's a database in that way. So difference is this is more open source and not so much government based. So that being said, that wraps it up for today's lecture. So at this time, let's go ahead and open the floor for anyone who has any questions. Okay, the floor is yours. Go for it. Does anyone have any questions today? Okay, no questions? Well, then let's go ahead and let's end the call. Everyone have a great day and happy coding out there.